Hello, these are the solutions to the AP Physics 1 quiz number 1.3, which is a vector quiz. So in this quiz, we have 5 different vectors, 1, 2, 3, 4, 5, acting on a box, and we want to know the magnitude and the direction of the net force. So we're just adding these vectors together. So I'm going to go ahead and just label them A, B, C, D, and E. So when we add vectors, the first thing that we need to do is to find all of the components for the vectors. So in this case, if I look at first A is going strictly to the left. So we can say that AX is negative 11, and negative because this is going in the negative direction. And since it is not going up or down, the y component is 0. Then for B, we have purely an upward vector. So BX is 0, and BY is positive 5, since we're going up in the positive y direction. C gets a little more interesting. So C has a horizontal and a vertical component. So I have a vertical component here and a horizontal component down here. So the vertical component, actually I'll do the horizontal first. We'll do the vertical. The vertical component will come from finding the opposite side to this angle. So that would be 14, the hypotenuse, multiplied by the sine of 30 degrees, which is just 7. And the x component will come from the, I'm going to do this in the same order, will come from the adjacent side. So that'll be 14 times the cosine of 30 degrees, which, if you let me calculate real quick, is 12.1 approximately. And both of these are positive because we're going to the right, which is positive, and up, which is positive. Then D, which we kind of wrote over top of down here, is 3 to the right. So my x component is positive 3, and my y component is just 0 since we're not going up or down. Finally, for E, we're going straight down, so our x component is 0, and our y component is negative 17 since we're going down. So to put all of these together, we now need to add all of the components in the x direction. Then we're going to add all the components in the y direction. So the net force, or the resultant force, the x component, will be all of the x components added together. So if we do that, AX is negative 11, BX is 0, CX was positive 12.1, DX positive 3, and EX is 0, which is, quick little tappy tap on the calculator, 4.1. So it's positive 4.1 is what I found. Then for the y direction, we're going to do the same thing but with the y components. AY plus BY plus CY plus DY plus EY. Woo, lots of y's. And so my y component for the A is 0. For B, it's positive 5. For C, positive 7. For D, 0. And for E, negative 17. So my y component for my overall vector is negative 5. And so these are the two components for my resultant vector. So if I just sketch this out, so I'm going to sketch some axes real quick. So here's my x and y axes. This vector will have a component of positive 4.1 in the x direction and negative 5 in the y direction. So now we just need to find the overall vector. We'll just call it R. So we have two pieces to it, magnitude and direction. Magnitude, so the magnitude of r is going to be from Pythagorean theorem. So I have rx squared plus ry squared. And substituting here, that's going to be the 4.1 squared plus the -5 squared. And so the magnitude of this vector is, let me do that real quick, about 6.47. And it doesn't really matter, but the units here would be newtons, since those are the units of all of our vectors. And that gives me the magnitude. Now we can go in and find the angle. So this is my triangle, so I'm going to go ahead and just find this angle right here. So this angle is going to come from using the tangent, since I know rx and ry. So the tangent is the opposite side over the adjacent, so that'll be ry over rx. And I'm going to rearrange this by using the arctangent, or the inverse tangent, of that ratio, ry over rx. So just substitute in your rx and ry values. So ry was -5, parentheses, and rx was 4.1. So we want to find the inverse tangent of that, which is -50.6 degrees. And that's it. That's all we need for this problem. So again, for vectors, you find the components, you add the x components together to find the resultant x component, you add the y components together to find the resultant y component, then you can find the magnitude of my overall resultant by using Pythagorean theorem, and the angle from using the tangent or arctangent.